Miguel Garcia, and I'm going to show you a cool effect using a hairdryer and a ping pong ball. As you can see, we can make the ping pong ball float with the air from the hairdryer. This is not surprising. After all, we have the gravitational force on the ball pointing down and the force from the air pointing up. The two forces are in equilibrium, allowing the boat to float. But is it this simple? Let's see what happens if we tilt the dryer. The ball is still floating, but these two forces are not antiparallel anymore. The gravitational force still points down, but the force from the air points diagonally as shown. These two forces cannot be in equilibrium. Why these forces cannot be at equilibrium? As we can see in this diagram, the force of gravity only has a vertical component, but the force of the air has both vertical and horizontal components. We have a horizontal component pointing to the left, which means we need a force with a component in the right direction to keep this ball at equilibrium. What could be this force? One possibility you may think is air resistance. However, air resistance is a force proportional to the object's velocity, which is zero or very small in each case. So air resistance is not the missing force. So how does this work? The explanation for this effect can be found using the Bernoulli principle. According to this principle, the pressure of the fluid decreases the faster the fluid moves. Therefore, the moving air from the dryer has lower pressure than the air surrounding it. The ball is in a low pressure region surrounded by higher pressure air. The forces produced by this high pressure air are what keep the ball in its place. This principle has many real-life applications. For example, football players can spin the ball to make it follow a curved trajectory. The ball spins create a region of different pressure at each side of the ball, allowing it to move towards the low pressure side.